Okay, hello everyone. Thank you very much for making it through to almost the end of J4. The only thing between you and beer is a security session with me. How did that happen? But anyway, we're going to be talking about some common vulnerabilities that you wish you didn't have in your Java application. We're going to be doing a lot of hacking. So, well, I say we're going to be doing a lot of hacking. You're going to be doing a lot of hacking. I'm just going to type what you say. So I'm going to ask for a lot of feedback from you to kind of, and from the back, you're going to have to really shout. My hearing's not great at the best of times. So I'm going to ask you how we're going to hack some of these environments, some of which I'm going to just show you, some of which I'm going to ask for your feedback. So I'm Simon Maple. If you wanted to follow me, feel free at SJMaple on Twitter. I work for a company called Snyk, which is a security company, hence me giving a security session. A little bit about some of the things I do. I run the virtual jug with a number of other people, also help with the London Java user group, and some other stuff. But I'm a developer advocate for Snyk. So, who's heard of DevSecOps? Keep your hand up if you like the idea of the name DevSecOps. 1, 2, 3, 4, 5, 6 people like that name. I hate it. I really hate it. It's like someone thought DevOps was a really cool thing, so they thought, why don't we put sec in the middle of that, and then we can be cool too, right? No, it's basically thinking about how we can bring security down to the developer level, okay? How we can get developers to think about security early. And putting security into a developer pipeline. This is what DevSecOps is. If we think about what the problems are which DevSecOps is trying to solve, is one of the biggest problems is as we find companies really trying to speed up their path from development to production. Who's heard of the phrase digital transformation? Another bullshit term, huh? Right. How can we speed up how developers can write code and then push that to production? What we really want to do is, rather than just speed up one little bit, we want to add performance into that. We want to add security into that, so that every piece of code we push has been properly performance tested and security tested. There's also the lack of security focus. Okay, we don't want to just do security once at the end. We want to build and bake security in from the very start, from our design all the way through to our production and beyond into our monitoring as well. And what we've seen is, departments, this very often happens with developers and operations, hence DevOps, but it also happens with security. We have their own security team, and the only time we ever hear from this security team is 2 days before release, when they give us a book this big with every single vulnerability that we have in our application, and we're told, you need to fix this before you release. And we say, we'll do that on the next release. And the next release it gets thicker and thicker and thicker, okay? So we need to bake this in. And of course, that little thing, that customer data could be compromised. There's that little detail as well. So how bad is this situation? We're going to look at some of the stats that we have from a report which we called the State of Open Source Security, as well as look at some other examples like this one. This is who's heard of Equifax? Who heard of Equifax 2 years ago? See, that's good marketing, right? So one of the biggest blunders in security leaks was the Equifax hack. Now, Equifax is just a regular company that happened to use Apache Struts. Any Apache Struts users in here? And I say user like it's a drug. One at the back. I think there's more than one person, just a brave soul at the back. So Apache Struts has numerous remote code executions, one of which is the one which led to this. Now, there are a number of things which occurred throughout this process. It wasn't just one single break. But one of the key parts of this is it wasn't a single break against Equifax because of this Struts vulnerability. This Struts vulnerability was used by many, many different environments, many, many different companies using this Struts library. And it just happened to be Equifax that made the headline. But if we actually look at what is being targeted, the number of Struts attacks that occurred at that date when the exploit was made available rose massively. So attackers are targeting known vulnerabilities rather than a specific company like Equifax. So let's pick on JavaScript because 1, it's easy, and 2, it's more fun. So if we look at NPM, NPM has over 400,000 packages. Okay, it's by far one of the biggest kind of resources that are available for us to download open source libraries. 6 billion downloads per month and over 70,000 people who publish to it. If we think about your application, that's your code. and the rest of it is pretty much just libraries that you deploy with your code. Let's take an example, and I'm going to ask for some numbers here. This is a 19-line code, 19 lines of code node application, which simply just fetches a file and stores it on Amazon's S3. Okay, 2 dependencies, as we can see just there, AWS SDK and node fetch. So 2 direct dependencies. How many indirect or transitive dependencies do you think this application has? 600. Okay, it's node, but it's not quite that bad. 19 dependencies, okay? So what we think we're deploying, 19 lines of code, actually pulls in 19 dependencies. 191,000 lines of code that is actually being deployed. So when you think you're deploying 19 lines of code, you're actually deploying almost 200,000. So what we push into our production is very different to what we see in our IDE. Let's take Spring as an example. Spring users? Wow, loads of everyone. Okay, so this is actually a Spring serverless example. So this is using the Spring Cloud functions. It's an application which we then deploy onto Amazon. 222 lines of code. How many dependencies do these 222 lines of code have, do you think? 6? 5, close enough. I won't give you any prizes there. You're 1 out. How many indirect dependencies do you think this has? 600. It's not Node. Any others? 30, a little bit more, same kind of order. 54 indirect dependencies. How many lines of code do you think this has? Too many, you're right. Almost 500,000 lines of code for a 222-line application. Okay? So what we deploy is very different to what we actually write. So open source usage has exploded, and attackers are targeting open source libraries. So they're targeting the dependencies and the vulnerabilities in those dependencies. Because one vulnerability, as we see with Struts, have many, many victims. So attackers can attack anyone who uses those Struts libraries. Right, let's take some numbers. This is the State of Open Source Security report, which we wrote last year. The survey for the next year one is actually open now, so you're welcome to do that as well. Take that as well. So this is NPM packages. As you can see, the usage is massively increased. Almost doubled within 1 year. This is from 2016 to 2017. If we look at the number of packages which are indexed, here Maven refers to Maven Central, year on year from 2016 to 2017, there is almost a 30% increase in the number of packages being indexed into Maven Central. How many of 430,000 sites have shown at least one front-end library with one front-end vulnerability? How many do you think? 90? Full of optimists here, huh? 77%, 3/4 of sites that we measured have at least one front-end vulnerability. Here's one that Java does win in. The number of critical package vulnerabilities, okay? You can see it increasing much faster than Node. It's great adoption. Number of open source vulnerabilities published per year. What's the name of this graph? Exponential. Just like the use of the term exponential, it's increasing exponentially. So, how often do maintainers actually react? Well, typically when a maintainer hears about a problem in their code, just over a couple of weeks, and they've made a fix into their code base. But vulnerabilities tend to exist for a few years, 2 to 3 years, as a median average, before they're actually found. So vulnerabilities exist in our code for a long, long time, but typically until attackers know about them, until they're known, that's typically when you're most vulnerable. Docker, who uses Docker? That's a pretty cool new technology, right? There can't be any vulnerabilities in that. What percentage of the top 1,000 Docker containers have at least one known vulnerability? 40, any others? 500? 500%? Wow. 76, about very, very similar to the front-end vulnerabilities, right? 3/4 of the top 1,000 Docker containers have at least one known vulnerability. So, ready to hack, let's go. I have a number of hacks. How much time have I got? Just to double check. Cool. I've got a number of hacks that we're gonna go through today. Where have I put them? Here we go. Number of different hacks that we can exploit. There's a zip slip hack, which is an arbitrary file overwrite when you're trying to extract zip files. We have a Struts, the actual Equifax hack, which got the attacker into Equifax in the first place. Interestingly enough, that got an attacker into the behind the Equifax perimeter, but it took over a month something like about a month to 6 weeks before they actually made, made the breach. Attackers were existing in that environment, okay, for over a month, gathering information, trying to find better ways in, trying to find where the data is before they were able to get, I think it was like 140 million users' information. We have Spring Data REST, which is a remote code execution called Spring Break. The first time I Googled for that, I got a bit of a surprise. Type manipulation from the Dust package, which is actually a Node application. We have a marked package, which is a cross-site scripting, but there's a subtle difference, which is quite interesting. I can show you. We have directory traversal, which is a fairly common one, but this is an interesting one where you can actually view. This is a knowledge-finding one where you can actually read from the file system. We also have an MS package, which is a denial of service created by regular expressions. Who likes regular expressions? Wow, more than I expected. And then we have Jackson. Everyone uses Jackson, right? Loads of people use Jackson. So Jackson, this is a remote execution, a remote code execution, which is based on an unmarshalling of Jackson. So if there's anything that people particularly care about, shout it out now. Jackson, anyone else? Regular expression, anything else? Spring Data, anything else? Okay, so we'll make sure we do Spring Data. I'll do unmarshalling, and what was the other one? Yeah, these regular expression fans, huh? Right, let me start off with, I'm going to start off with the ST package, because that's an interesting one, then I'll go to some of those ones. So, now I'm going to show a cross between Java applications, Node applications, and I'll do one. You asked for the Jackson one, which is actually a serverless application, which is running on Amazon Lambda right now. So I'll show you those different applications. But the key thing is, a vulnerability is a vulnerability, whether it exists on a Node application, a Java application. It's just a way of exploiting. So it doesn't matter too much about the application, but I'll show you a couple of examples. So this is a Node application, and I'm going to show you a directory traversal vulnerability that exists here. So here I can just type hello, I can type buy milk, just to show you how this application works. If I want something really important like beer, I can do that, and we get a bold, so it's got markdown as a result as well. I've also got an about page, which is served from the public directory. So with just what I've shown you already, first of all, who knows what a directory traversal vulnerability is? You put your hand up first, sir. You can tell me what a directory traversal is. I literally have no clue, so please tell me. Exactly that. So we're gonna effectively break out of the directory that the application wants us to be in. Okay, so we're traversing outside of the directory and potentially looking at sensitive files. You wanted to do this at the URL, so I presume at the URL bar. So I presume here, right? Okay, rather than that, because if we're going to pretend to be hackers, let's try and do it at a command line. Okay, right, so here, can you view that at the back? Yeah, all good? Right, so I'm going to type st1. Okay, this is just to save me some typing. Okay, so what I'm going to do is I'm going to curl the about page. So what do we need to do to traverse this? Double dot. Something like this? Okay, hands up, and again. And again and again. Who thinks that's going to work? 1 person, 2 people, 3 people, 4. Okay, does it work? No, it doesn't work. Because what's actually happening is, the ST library is a real library. This is a real package. We're using existing packages in our application. Okay? And it's recognizing that we're doing a .. It recognizes you are trying to do a directory traversal. I'm going to push you back to my home page. Okay, so what else can we do? Escape it. Let's remove some of these, and you want an escape like this. Same thing. Encode them. Who said that? Do you know what the encoding is for a dot? Oh. Anyone know what the encoding is for a dot? 2E. Who said that? Right, I got your number, right? You're a hacker. I know you're a hacker. There's no other reason why you would know that. So %2E. Who thinks that's right? Who thinks that's going to work? A few more people. Boom, directory. Okay, here's the public. Okay, what can I do now? Going up again, right? So let me grab this. copy, paste. We can do as many as we want, because if you do a cd dot dot in the root, you get the root. So I can do that. There's my root. Now let's try and find something sensitive. Etc. password. Okay? So what we've found is, with just some simple directory traversal, we can read the file system. We can get sensitive files. We can get config files. We can understand what's installed. Okay? We can't necessarily run anything. We can't overwrite anything, but we can read. And that, the reading, understanding what's installed at what versions, having a look at what vulnerabilities exist in those versions, this is the knowledge capture that we get. Okay? So, say again? So the question is, wouldn't that imply that the server is running as root? So you are, yeah, whatever access that process has, you are within that. I mean, sometimes you'll only have specific volumes. So when you actually do get in, particularly with remote code executions, you might get into a volume which is read-only. It will reduce what you can actually do. But here, you can potentially look at the application. You can have a look at what's running, have a look at maybe read what's in the actual files of the application. There's a whole bunch of things you can do with this. But yeah, you are restricted to the security of that running environment. Any other questions? Okay, while we're here, let's do a regular expression denial of service. So, who knows what a regular expression denial of service is? Anyone? Sir? So that's subtly different. That's I think that's XEE, which is the entity expansions. This is the death by a million laughs, right? Where you go ha 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 ha. This is subtly different. It's similar in that what that actually does is it kind of kills your memory, right? Kills your resources. This is a regular expression denial of service. So what we're going to do is, who likes writing regular expressions? You know my next question, right? Who likes reading other people's regular expressions? Right. You can see the masochists in the room. So what we're going to do is let's pick a regular expression, right? Let's grab a regular expression like if I was to do something like this. Okay, this is my regular expression, and this is my pattern that I'm going to try and match. How is this? This will match, of course. How is it going to match though? Is it going to match with the A+? Or is it going to match maybe the A+ for the first half and the star for the second half? Or is it going to match the A+ once and then the star many, many times? Ultimately, there are many different ways in which regular expressions can be matched. So a regular expression engine is going to completely go back. It's going to backtrack, basically. It's a backtracking algorithm. So if it can't match, it will exhaustively try the list, the full list, until it will say, there is no way I can match this. Okay? And that is the key to how we're going to actually create a regular expression denial of service. So with that knowledge, I'm going to come, where am I? I'm going to come out, and of course we are going to continue at the command line. I'm going to type ms1, and this is going to, what is this going to do? Let's see. This is going to call, I'm not going to call my American mom, I'm going to call my English mum, in 20 minutes, okay? Returns very, very quickly, okay? And if I go over here, I'm going to call my mum in 20 minutes. Now, what I'm going to do this time is I'm going to type ms2, which is going to do something subtly different. It's going to effectively flood this request with 60,000 fives. So I'm going to buy milk in 60,000 fives and then minutes, okay? We run that, comes back very, very quickly. Why does it come back so quickly? Because the server is down. No, the server is definitely up. It's essentially because it matches. Okay, it matches, and it matches very, very quickly because there's no errors in it. It's matching just fine. If I was to come back here and refresh this, we're buying milk in infinity days. Lovely. So how can I break? How can I break this? How can I put it into a backtracking? Buffer overflow? No, not buffer overflow. Any others? Say again. Make it non-matching. An example. Like this? You're a hacker as well, huh? If I run that, bang, it's waiting. It's doing nothing. It's trying to match that. It's backtracking to 60,000 fives. And that's hung, okay? Until it goes through every single one of them, boom. Okay? If I was to add another 0 on that, we would be waiting all throughout tonight and tomorrow. Okay? So a regular expression denial of service, this is a regular expression which is struggling to complete, struggling to match, and as a result, it hangs that thread. Who uses serverless here? One person at the back. That would have been really expensive for you, sir, because what happens is when that thread hangs, another one pops up, and then another one, and another one, and another one. That's a denial of pocket money. Okay? So that's a regular expression denial of service. What others did people like? So we've done we've done Spring Data REST. So who uses Spring? Who uses Spring Data? Who uses Spring Data REST? Few people. Who's heard of Spring Break? And I'm not talking about the American thing. No one's heard of Spring Break at all. It's a remote code execution which occurs. It's very similar to the Apache Struts one, actually, because there's no setup for it. Once you're using this environment and you expose a RESTful endpoint, we effectively pass in this key set of characters as data into the header, and as a result, it's just exploitable, and we have remote code execution. So let me show you the application first. Okay, so the application is here. Spring Boot application. Okay, so it's my Spring Boot app. Is that okay for size? No? How's that? Okay. So this is just my Spring Boot application. As a result, I'm going to actually do some initialization where I'm using a Spring Data repository. I'm going to add a whole bunch of grocery items. So this is a grocery list application. Okay. My item is just effectively a string with a name and then a cost associated with that. And then we have our repository. Now our repository, in this case, is a CRUD repository. This is just an interface, and Spring Data behind the scenes will implement this interface based on the methods I add. It's very, very nice. But what makes it the Spring Data REST is this annotation here, repository REST resource. And this allows me at runtime to access the data behind this repository just through a RESTful endpoint. So, as a result, I've already got this installed. If I go to localhost, why is that not? There we go. Localhost 8080. I've got my HAL browser. And here I can see that I've got a couple of things that I can run, one of which is items. So if I type items here, I can see everything which has been initiated, beans at 50p, milk at £1.09. I have a feeling after March that's going to go up. If I wanted to, I can put /2, and we get milk at 109, and so forth. It's just a regular environment. So what I'm going to do to actually break into this now, I'm going to jump to my my Spring environment, and I've got a couple of. If I show you the JSON first, so let's cat this. This is what we actually need to send in. Into the header, and it's effectively just we're going to substitute this command on the third line on the left-hand side with something which we can execute with. We're effectively getting the runtime. We're running in a runtime.exec on it. We're grabbing the output, and we're going to return that back to us. So if I was now going to cat the string REST exploit, let's say password. Actually, no, let's go for environment variables. If I was to cat that and grab this, and it is running on my local host, yep. So what I'm going to do now is I'm going to curl this. I'm just using curl, nothing else. This is my data that I'm sending in, and I'm hitting my local endpoint. Nothing needs to be set up here. I'm just hitting an endpoint that exists. If I run that, bang, we get the environment variables of this machine. Okay, so running locally. If it was running remotely, you'd get exactly the same thing. Question: who puts their usernames, passwords in their environment variables? This is a safe place. You can put your hands up. Don't worry. Right? Now we have to care about what's behind the scenes, things that we think is kind of behind our perimeter is potentially accessible by other people. And as soon as people can get username and passwords, they might be able to get in alternate ways. Okay. The fix to this is obviously just to increase the version of your dependencies to a version which has these fixes in. It's as simple as that. Right, so we've done Spring Data, we have done ST, we've done MS. Right, Jackson, you want to do Jackson? Okay, so for Jackson, what I've got, this is actually in my we're going to hack now an application, a Spring Cloud function, which is running on an Amazon Lambda. So this application, let me quickly just show you this application to do. So in this application, we just have a bunch of functions, just like this, okay? Now these functions, to create, the Spring Cloud Functions is effectively just a programming model. It effectively uses Spring Boot. And what we effectively do here is we have a component called the create-to-do function. This function has basically request and response objects which pass through from the serverless framework. And we are using our repository, and we're just going to add and save things. So it's a really straightforward, simple function. One of the nice things about Spring, of course, is you just write your business logic, everything kind of gets done in the background. Now, there's also an import to do. And the import to do uses JSON to unmarshal and marshal things. So if I come back here and I show you, actually, let's go back here. And I show you a couple of my application files. So let's do this one first. So this is a piece of XML. This XML contains a bean containing a process builder. This is what is going to be unmarshaled by JSON. And this is the object that's going to be created and executed. We're going to create a process builder. That process builder on construction has 3 values, bash, -c, and the command, and this is what's going to actually be then executed on the runtime, okay? Now what we're going to do is we're going to send a file. It's going to be a data binary file that we're running. It's going to send the etc password of that machine across to this environment. This environment is actually an ngrok, so it's tunneling straight back to my laptop. If you're going to do anything like this, which I suggest you don't, I would set up an environment, a little HTTP server on perhaps a family member's machine. Some way that it can't be traced back to you, and then you're good. I normally use my wife's. In this case, I'm pushing it back to mine. So we're going to execute this curl. So let me go across to here. Here's my ngrok, which is running and accepting requests. I'm going to come over here, and I'm going to say, whoops. Oh, geez. There we go. I'm going to send in this spell etc pwd. The hack is actually, in this case, just to actually add this, instead of passing it regularly, we add this little context object here, and we pass in a file which is going to be used as our input. This file is going to be the etc password. This is exactly what I just showed you there. We're hitting this. This is our server running on our Amazon instance. The dev import. This is a curl, so there's an API gateway which exists in our deployment into Lambda that allows us to access these resources via HTTP. So which is why I'm allowed to curl this. So I'm going to run that. I'm actually going to run it a couple of. It's just, I think this is because this is a serverless instance, sometimes the functions are down and they need to start up, execute, and close. Now, if you use things like Node, things happen very, very fast, like that, because it's obviously warmed up now. If you use something like Java, and in this case, Spring Cloud Function, what we're actually doing is we're deploying, and keep with me here, a server onto our serverless instance. Now, this is effectively Spring Boot, so it's a Tomcat server running embedded in that application. So now if I was to come back here, it's not quite doing it yet. Don't fight me now. Oh, I think I see what the issue is. Oh no. Why do demos never work, huh? Okay, let me restart this ngrok. Let me grab this. I'm going to update my etc update this with that, and I'm also going to do, actually no, that's fine. Then I'm just going to put this into GitHub, and then we're going to run that again, and hopefully that's going to work. Otherwise, I'll show you one I made earlier. There we go. So let's try that again. Oh, I see what the problem is. Why did no one pick this? Everyone's watching this, but no one's picking me up. Let's try that. Let's run it a couple of times. If you think demos are bad, you try hacking, and it's even less likely to work. There we go. Whew. Saved finally. Let's see if we get this here. Right, here we go. If I was to make this a little bit bigger, whoops. Okay, this is the etc password file being sent back from our Amazon Lambda instance. So we're now accessing the etc password just by invoking our application, okay? One thing to note here is, what the hell are all these users doing on this box? I thought this was just for me, this little Lambda, but yeah, wow. So you can start gathering information on here, and then of course you can actually do remote code execution. So if I wanted to, in fact I'll show you a couple of others while we're here. Let's do, if I run this, I obviously need to update this with my grok file and list temp. Show you a couple of others. And then I'm going to just commit this into Git so that we're using the right versions. Right, so the two I'm going to show you now is an interesting one actually with Spring Functions, or with Lambdas. The first thing I'm going to do is actually just do a find of everything whose name starts with or has to do in it. Pass that over to a find to-dos.txt, and then send that back to my ngrok instance. And that is called find to do files. Okay, so if I run that here, so this is spell find to do files. Run that a couple of times just so we make sure we've got something in our buffer. See if we have something here. Not sure why it's being so slow right now. If this doesn't work, I'll show you another example. Please work. Okay, here's one I made earlier. If I was to show you, not this one. Here we go. So you can see here. What you can now get is, because we've got remote code execution, you can actually view different files that exist in your environment. You can grab them, you can decompile them, you can re-upload them, and you can actually change the behavior for following users. Because one of the interesting things, if we was to look at what we could do is, if we actually view the temp directory, which is this one here, if we view the temp directory now, we can see other files that we've stored on there, list temp. Okay, this exists because when serverless environments, when functions are invoked, we think they're invoked. They come up, they're invoked, and then they go down again. Okay, but what actually happens is they only really come up and down based on load. So if a function comes up, we can send loads of executions to that function, and it's not stateless. Okay, if I was to mutate that in any way, make changes to the code, make changes to the file system, add TCP listeners, I can actually start listening to other people's traffic or updating code. But again, it very much depends on what permissions I have on that volume. So that is one of the, all of that was pretty much done all through that JavaZone vulnerability. Okay, not that one, this one. So that's the JavaZone vulnerability. What else do we have? How am I doing for time? Still got a little bit of time. We have zip-slip, we have Struts. Struts is very, very similar to the Spring one, so we'll leave that one till a little bit later. Anything else anyone wants to see? Zip-slip and what, sorry? The marks package? The mark package, this is an interesting one. This is a cross-site scripting one, but it's slightly different to the usual kind of cross-site scripting. I'll show you this one. This is actually back in the Node application. So, cross-site scripting is where we're able to actually embed scripts into a page, okay, and execute those scripts. So I would obviously do that here. So let me clear this out. I would typically do that here. How would I try and inject my script into here? Script hello world, so something like this. Let's try it like this one first, and the script would be, what is it, JavaScript .alert, something like this. Which I think is it this or is it just that? It's just alert, isn't it? Okay, who thinks that's going to work? It might. It doesn't. And it doesn't because if I actually come back to the application, if I was to cat the app.js, we have set the options on the marked library to actually sanitize. For some reason, sanitization was set off by default. So for some reason, you could use this and have cross-site scripting exposed by default. But we've set it to true. So we're actually sanitizing this on the way in and the way out. Okay. So let me give you another clue. This is a problem, an issue that is in the marked library. So what do you think? So this is Markdown. So what kind of cross-site scripting can we add in Markdown? Say again? One more time? Code block? That might work, but we're not going to do that just for time. 2 stars, not quite 2 stars. Think about how we can actually inject a URL or some kind of script. Links. Links. So something like this. So if I was to do this and then just put something like that, we can actually just inject a link. This is absolutely fine. But what if I wanted to do a bad link? What kind of link are we going to add in here? This one is the JavaScript one, isn't it? Something like this, okay? Right, who thinks the link idea is going to work? Few more people, okay. It doesn't work, and it doesn't work because it's there, but the library knows what we're trying to do. The library knows we're trying to inject this script into our runtime, and it's actually blocking it. It doesn't like 2 things. It doesn't like this, and it doesn't like this. Okay, any other ideas? Encode it? Right, who did 2E? Right, what's the web encoding for a, you don't know, anyone else? I'm surprised. It's, hang on, I've written it down. It's ampersand hash 58 colon. Yeah, now you know it, right? Yeah. Oh, yeah, that. Yeah. And then it's 41 for that. Okay. Who thinks that's going to work now? A few more hands. Oh, not quite. And this one is actually a vulnerability that was fixed in the marked library, but is actually exposed through a browser. Okay? This is a browser. Aren't browsers wonderful when they think they know what we're doing and they try and make life better for us? This is exactly what happens here. I'll show you what we're going to do. I'm just going to type this there. All right? Now, in this case, this part here is not a semicolon. Because it doesn't, sorry, it's not a colon, because it doesn't have a semicolon at the end. All right? And we have this here, which doesn't quite work. So this passes marked. Marked has no problem with this at all. Sanitization, absolutely fine. But when it comes to our browser says, oh, look, this is almost a colon. I think I know what you're trying to do. Don't worry, I got your back. I'll fix this for you, right? So if I run that, then we get our bad link. If I click that, then we get our alert, okay? And here, of course, now I can grab your document, I can grab your session data, I can behave like you. This is an interesting one. Now, this is a fun one as well, because marked is essentially doing the right thing. It is not a colon, so it's allowing it to go past. But when we think about whose responsibility it is, just because it's neither the browser's nor the marked library's responsibility, doesn't mean one or the other shouldn't fix it. So marked took the responsible step and actually fixed it within their library. So that's a fun one. Right, zip slip. How have I got time for zip slip? Just about. Have I? 40, 50, yeah. Just about time. I think this will be our last one. So let's go across to my to-do list here. This is just a regular to-do list. If I wanted to, I can create to-dos. I think this is a Heroku app, which is probably timed out. So I'm going to run that again. I can create my to-dos, but one of the things that it allows me to do is upload my to-dos. So I can upload a zip file with all my to-dos, and it will very helpfully allow me to add them into my list. As soon as this comes back, let me just check the logs. Okay, it's stopping all processes, so that's fine. It's going to come back. There we go. So let me sign up. Right, Simon at Snyk.io, 1 to 6, 1 to 6, bang. Okay, right, here we go. So I can create to-dos if I wanted to. In my to-dos, I can just say buy flowers. For my wife, maybe, because I'm traveling too much in November. I can say, yes, any date. I can say 1970, so that should be hi. I can create those, bang. The other thing we can do is let's grab the pi character. This one here, pi. Okay, not you. Goof, no, to-do list. If I was to say create a to-do, and this will be buy some pi, whatever, and hit create, we're running through a command in my logs. You'll see it here, which is a native to ASCII JDK command. Okay, this is just a script running in the bin directory of JDK. And what we've done is we run through that and we convert from buy pi to buy whatever that is. It looks less tasty than pi, but there it is. Now, what I'm going to do now is I'm going to take a look at in here. We have a zipslip.zip, and I'm not going to cut it. I'm going to jar minus tvf this. Okay. Now, in this zip file, we have a good.txt, and this is very similar to a directory traversal issue. We have a good.txt, which is going to be opened into this directory, into the target directory. This is all going to be pushed into the public directory when we upload it. We also have this, which, as we know, is a directory traversal. It's going to go right back to the root, and it's going to overwrite my native to ASCII. Okay? If I was to cat my native to ASCII, we get just an echo of mwahaha, gotcha. Okay, so it's going to overwrite our title. So if I come back here and I click Upload Files, choose File, and this is going to be, let's just go, actually I need a specific one, so Simon Maple, Snyk, oh my god, Java Goof, exploits, zipslip.zip. Okay, I'm going to upload that one. I hit Upload. In our public folder, oh crap, there's only good.txt. Okay? If there's no exceptions and there's only a good.txt, there's a good chance that the directory traversal did actually happen. If there's only one way we can really test this. If the directory traversal did happen, let's do something here. Let's go enjoy J4. Sorry, I almost forgot which conference I was at. J4 beer. There we go. If I was to create that, oh dear. We've got a native to ASCII file, and the JDK has been overwritten, and now we're executing on some malicious code. This is what a zip slip is. It's when you try and extract a zip file, whereby you are trying to save the files in that zip file, which has malicious directory traversal paths into your target directory, and as a result, you traverse out of that directory. So, that's all well and good. We've had some good time hacking, but what can we actually do about it? Well, there are tools around. I'm going to show you a tool called Snyk very, very quickly. Everything I'm going to show you is completely free. Okay, this is a product that my company my company produced, but it's entirely free. From here, I can actually add some integrations. From my integrations page, if this is going to load, I can add either projects from my source code, source code management environments, as well as paths, as well as look at lambdas, and actually take a look, if I wanted to, at specific projects. So in this case, if I click on Add Projects and maybe pick, we've got Java Goof or Goof there, for example, I can add that into my repository. And this is now going to import this. It's going to create the directory tree, and it's going to actually tell me where my vulnerabilities exist. So if I go back to my current projects, let's take a look at Goof, which is this one here. I can click. In fact, this is a Node one. 470 dependencies because it's Node. If I look at this, I can open up my dependency tree, see where my vulnerabilities exist. I can take a look at what my vulnerabilities are. I can even open a fixed PR if I want and actually upgrade to the latest version, or not the latest version, but the minimum version whereby that vulnerability goes away, is eliminated. And as a result, I can sit on versions which don't have known vulnerabilities. Now, this is, of course, if I wanted to, I could just go here, open a fixed PR, and it'll push this to GitHub. Now, this is just a tool, okay? And you need way more than just a tool to fix your environment, right? What you need if I come back here and go here, the solution to this isn't just tooling. It's team culture, it's process, and it's tooling. The tooling we can use, something like Snyk or something like OWASP or whatever you choose to use, just allows us to not have to go in manually through every single package and say, has this got a vulnerability? Has this got a vulnerability? Okay? It allows us to automate that. But what we need to do is change our team culture. Change our team culture so that we have security people who are involved in our development teams in the same way a DevOps culture would work, where we break down the silos so that security people are involved from design, development, all the way throughout to production and beyond. Okay? Process is very important as well. Who likes process? Wow, that's weird. That is weird. What kind of process? Who likes security process? One person at the back, and I don't believe you, sir. So, we don't want, what we want to do as developers is write code and get features out, right? We want to know when things are broken and how we can fix them, but we don't want to go through huge amounts of process. So what we need to do is use tooling in our existing process so that we know when we're testing and how we can fix. And we can do this from development all the way through up to our testing, our CI, and our production. And there are many tools which allow you to do this kind of thing as well, including the tool I just showed you, but not just limited to that. There's loads of tools that are available. And it's important to actually use those kind of tools in your environment. So security isn't something that should be left to the end. It's cheapest and easiest as a developer to fix them when you're introducing new vulnerabilities in. Having that process so that when you actually raise a GitHub PR, you have a tool that will take a look at the delta of what the changes are being made in that PR. And if you're introducing new vulnerabilities, then you'll have a tool like Snyk or something like that to alert you to that. Okay? So it's really, really key to use tooling, change your team culture, and also update your processes. That's everything I had. I've got a couple of minutes left if there's anyone who has any questions. No questions. Hands up if you're scared. Quite a few people. Excellent, excellent. So, without further ado then, if you wanted to follow me, please do. Please let me know some feedback on the session as well. I'd very much appreciate that. I'd really appreciate your feedback into the using the apps and whatever else the NL Jug's asking you to do for sessions. Other than that, thank you very much for coming. I hope you really enjoyed JFall, and let's go enjoy some beers.